Hi, students. I'm really happy to be having this conversation with Peter Kress, who's a senior data scientist at Mathematica. Peter, thanks so much for being here.
Thank you. Very excited to get to share about my experience here and what we do at Mathematica.
Yeah. And Peter, so let's chat about your role right now. So what does it mean to be senior data scientist at Mathematica? What is Mathematica for those who don't know yet? And how did you get to your role right now?
Yeah. So at a high level, Mathematica is a fairly large public policy research firm. We have a long history of evaluating a variety of large public policy programs, starting off with, I think, earned income tax credit
Mm.
and related public policy evaluations in the 20th century. In the last 30 years or so, we've grown to a fairly large size, over 1,000 employees, and we evaluate largely centers for Medicare and Medicaid related projects, a large number of human services related projects, which largely sit in the Department of Labor, the Department of Education, a few other agencies like that. And then also international work and work sponsored by foundations. So the bread and butter of our work has historically been survey research and impact evaluations, which are often commissioned by the government, and increasingly in the last 15 years, as data technologies have advanced significantly, we've been doing more and more provision of technical assistance, technical services, and data science, data engineering related work there. So we still do a lot of impact evaluations, but increasingly we also build dashboards, build data collection systems, do geospatial visualizations, for example, for an overdose tracking heat map for the Boston and Baltimore area. So yeah, we do a whole wide variety of things. What I do as a senior data scientist, I sit in the data solutions sort of division, and so we have qualitative work and then we have more quantitative work. And as a senior data scientist, I'm really sitting at the nexus of the qualitative understanding of issues, public policy questions that are academics. Often, many of our employees have PhDs. They have spent time in the academy and are interested in whatever specific research question. And then we have a lot of programmers, data analytics developers who support the implementation of the programming for that. And as a data scientist, I kind of sit in between the two. And so I really enjoy my position here. I came from the econ research background right out of undergrad. I worked in economic consulting, litigation consulting in DC. From there, I worked as a research analyst or a research assistant at the University of Chicago, studying public policy issues. And from there, I found my way to Mathematica, and I think this is a really great combination of the economic consulting, many different projects, large teams, very collaborative, and also the public policy and pro-social impact that I was excited by when I was at the University of Chicago.
And you're taking a master's right now. So can you share a little about that and how that informs the work? And
Yeah,
that, in
that's
that sense,
right.
it gives us a segue into like the skills that are necessary for um, people in
Yeah,
data
yeah.
science.
So I'm taking courses while I work at Johns Hopkins in the Applied and Computational Math program, and that program is really helpful to continue ensuring that I can sit in this nexus between the subject matter experts and the implementation. So I've enjoyed taking more advanced statistics courses, probability theory, analysis of experiments, machine learning courses, those sorts of things. And they really equip me to be able to navigate the technical aspects of what's required for a project. So a lot of our projects typically come in the form of bidding on a request for proposal that's associated with some large evaluation or some large project. And so we might have work that's scheduled for several years away, and that work finally comes once we've collected all the data, and it comes to actually doing the analysis. And so these master's courses have helped ensure that I'm in a good position to think about which machine learning methods are most appropriate for a particular question. What are the threats to causal identification or causal inference that we might have in a certain setting? And in a more general level, what sorts of innovations have come along recently in machine learning and the Python libraries that support that. For example, using Shapley values to look at variable importance or other sorts of transparent AI, or increasingly learning how to use large language models. These are things that those master's courses have helped make sure the theory is advanced, and also that I'm exposed to a wide variety of methods.
Mm-hmm. And so with that, what are the skills that you think are technical and professional skills that are important in your field?
That's a really good question. Because our work is so broad, there's a lot of different versions of skills that are really important here. But from my own experience, what I've really found to be helpful, there are three kind of like key skills that I found really helpful. The first is as a senior data scientist, programming skills associated with turning a research question into an actual program that can deliver the results that answer that question. So every day we use Stata, we use R, we use Python, sometimes we use SQL, and a few other programming languages as needed, each in their own context when it's serving the research question that we're working on. So that broad understanding of how these different languages work, what their relative comparative advantages are, that's one important skill. So it's just kind of programming and being able to translate a question into actual sort of detailed implementation.
And code.
And code. And ultimately, usually a PDF or a Word document. The second key skill, I think that the mathematical skills that I have acquired over the years, and in particular, they're the causal inference mathematical skills have been really important for me. So those are they kind of come hand in hand, I would say. There's the first is the causal inference, like understanding what it means to evaluate a program is, it's a little nuanced, and it really helps to be able to understand what the subject matter experts, the academics, the people who are principal investigators on these projects are doing. So when they say, oh, okay, we'll evaluate a program, it's going to be a quasi-experimental design. We need to find a treatment group and a control group that's appropriate. We're going to use this or that quasi-experimental design strategy. To know what those mean and what challenges those might face. So that causal inference background. Some books that were helpful in that space were like the Causal Inference Mixtape.
I have that here.
Yeah. Okay, good. Yeah. Oh, I see it. Nice.
Yeah.
And there's a wide variety, as you know, of similar online resources for that. Obviously, coursework is really helpful there too. And then the other is like a machine learning and sort of more advanced data science skills. So the ones that come to mind most recently are large language models and also non-parametric models. So both of those are tools. They don't give you interpretation on their own. You need the causal inference understanding to know how to interpret your output. But these are tools that really help you get that output and make sure that output's as efficient or useful as possible. So on the non-parametric learning, let's say we're in a causal inference setting and we want to calculate propensity scores. which might help us compare a treatment group to a control group. And I know there's a lot of jargon involved here. You can do that in a lot of different ways. And what's helpful is to know, okay, this type of random forest, or this type of XGBoost, or this type of other implementation will fit well in this setting to predict the outcome. And so again, going back to the earlier point about the master's degree, it's just helpful to have sort of a big toolkit, knowing what might be appropriate for a specific problem if you encounter it. And then the large language models is an interesting one. I would say I think of it in this causal inference setting as like a subset of a larger set of tools that help you make use of unstructured data. So there's a lot of unstructured data in the world, and what's really magical is if you can tap that unstructured data to have it help you answer really hard questions. And so for surveys, you often have free text responses. Large language models are really helpful at helping capture the nuance that you can get in those free text responses. And you might want to incorporate that if you're looking at some evaluation. There might be some really important information in what people say in those surveys. Historically, we've had to kind of ignore that data or find other ways to incorporate it. This is a really cool, exciting opportunity to look for ways that machine learning tools like large language models enable you to tap that unstructured data. And there's a lot of other examples.
Are LLMs in this regard seen as, is it more like topic modeling, or is this even more sophisticated than that? Can you like query the data that you have, for example?
Yeah, there's a lot of different forms. You can have certainly versions that look a lot like topic modeling. And then you can also have forms that help you, for example, summarize case notes. That's one that we've been excited about recently. So, looking at a huge pile of unstructured text associated with a participant in a program, you might be interested in distilling that to a higher level so that a caseworker or a program officer can see really quickly, like, this grantee is struggling with this, or this treatment participant is struggling with this, to sort of surface that information faster. And then you can, structure that and say, this grantee struggled with this. And so when you're analyzing the grantees, now you have a new data point, a data point that wasn't filled out previously.
Great. Now, why don't we see this in action? And you mentioned about the re-entry project grants evaluation. Maybe you can share more about like how did you become part of it, or what's been your role, and also what's the day-to-day life like
Yeah.
for being in a project like that?
Yeah, that's a great question. I think this project kind of says a lot about, one, the scale and the breadth of what a Mathematica project can look like, and two, it says a lot about the different types of skills and tasks that are involved in getting one of these across the finish line. So I'll share my screen really quickly. If you can see. So this is on the Department of Labor website. This was a recent project that I was involved in, and it's actually part of a slew of similar projects. The Department of Labor commissioned several similar projects which analyzed different, largely adult training programs. And so this reentry project's grant evaluation, as you can see here, was an evaluation where Mathematica and a few other companies, we were evaluating how effective the grants associated with this reentry project were. And so there's a whole variety of deliverables that were associated with this. You can see that they come from all the way from 2019 to December of 2024, and the actual project started before that. And the main questions were things like, how were the programs implemented? What types and combinations of services and approaches were provided? What employment-focused services were offered? What impact does it have on the outcomes of participants? To what extent do outcomes and impact vary across subpopulations? So I worked mostly on the impact components, and there's also a whole other set which is on the implementation component, as you can see in these first two key research questions. The implementation is a whole interesting, fascinating world, and you probably know a lot about it, what makes for effective implementation. There's a 150-page report here that we prepared, associated with who the participants were and what they received and how they experienced these programs. But I'll focus a little bit on the impact evaluation. So the implementation report is kind of...
just zooming in?
Yeah, I can do that.
Thank you.
So if the implementation report is kind of more qualitative, the impact report is more quantitative. And this is where we do the quasi-experimental evaluation of the program. So at a high level, what we did is we were able to look at administrative data for the folks who participated in this program. This is a after criminal justice involvement program to help folks get involved with employers and employment training services once they re-enter the civilian workforce. And the process here, it's like a lot of making sausage, there's like a lot of different pieces. We took criminal justice data from various criminal justice agencies. Those are different state by state. Their data look different state by state, so we had to clean all of that. We took data from the grantees who administer these programs on their participants. There's many different grantees. They have different types of data. The Department of Labor sort of collects a lot of that. We collect it from them, bring that together. Finally, there's a whole database of earnings and employment information called the National Database of New Hires. So we brought these different administrative data sources together to evaluate how these programs affected the population. The challenge here is it's not a randomized control trial, so you can't just compare the outcomes. What we had to do is look for a group of previously incarcerated folks who participated in workforce training programs but weren't in these programs. Mm-hmm. And then we found that population. We used a machine learning model. We used Lasso with double selection to try and identify the group of those comparison folks who are most similar to our treatment group. And then we used that model to weight the control group so that it resembles the treatment group, and then we were able to compare the outcomes. And this was a very thorny process because there's so many different types of data. One reason I think this is a really interesting project is you actually encounter a challenge where you're not certain, if it's not a randomized control trial, if your outcomes are truly representative of true differences from the impacts, or if they're from the fact that these populations are different. So we actually ended up seeing negative impacts for this population.
Negative impact for the re-entry program, you said.
Exactly, yeah. But these patterns that we saw were based on pre-programmed criminal justice involvement. They may reflect unobserved differences between RP participants and the matched comparison group. And so the key thing here is we worked really hard to think about the best way to find a comparison group, but this is a setting with a population that's very at risk and can be challenging in the employment market. And so even with all that data, what we found, it made it hard to be sure that our comparison group is sufficiently comparable to our treatment group. Mm-hmm. And so that's actually an important outcome just from a public policy perspective. It's important to know what sorts of questions you can answer with a quasi-experimental design and which questions you can answer really only with a well-designed randomized trial. And zooming back out a little bit, I think that to me, this program like illustrates there's the implementation side, there's keeping track of all these different databases, there's the actual coding of the models that you're using to calculate the impacts, and then there's thinking about what those things mean in context of the data you're analyzing. So to me, this is a great illustration of the variety of skills, qualitative skills, causal inference skills, modeling and machine learning skills that all come together to try and evaluate a program like this.
This is a nice way of bringing together everything that you mentioned during our conversation, and I'm quite happy that you've really given us like the background of or the backside of what happens with these reports, right? Because oftentimes we just see the reports or see the headlines in the newspaper, but you really gave us the things we don't see, how the sausage is made, if you will. And so thanks so much, Peter, for taking the time and for sharing with us. I'm sure the students will learn a lot and we'll be discussing more about things that they're picking up from our conversation.
Yeah, thank you so much. It was a pleasure to talk to you. Always happy to share, and I'll encourage anyone who's listening that there's a lot of really important and hard work to be done in the public policy research space, and there's a lot to learn as a practitioner, and also to contribute to these really important questions. So, thanks again for your time, and I was really happy to share.
Thank you.